Get to say hi. Go ahead.
What?
Say hi.
Hello, Mary.
Okay. We're live at the palace. Here we go. Volumes of revolution. So we talked about this disk and washer method yesterday. Do you understand it's really not hard to memorize these, that they're really all the same version of the first one? That this horizontal axis of revolution is the same thing over here. It's just everything's in terms of what? And over here, washer is just subtracting out another washer. Okay? This is still a washer. Pi r squared dx. Pi little r squared dx. That's a big washer minus, or sorry, it's a big disk minus a small disk. Okay? Same thing over here, just in terms of y. But you need to memorize them. You got to have them. You have to have those formulas to be able to do the AP exam. They do not give them on the AP exam. Okay, they're not there. So if you are trying to think Mr. Morris is just saying that, no, I'm really not saying that. They're not there. You have to know them. Okay? So here's the steps, and remember we went through this yesterday, and here's kind of the idea. So we have a curve, we have from A to B, and let's just visualize this disk again. It starts with a rectangle, though. So you have the curve, you have the area under the curve. And so you imagine one rectangle, call it the vertical strip, and that rectangle, since there's an infinite number of those rectangles, that rectangle has a very, very small width. Does that have a width? It's infinitely small, but it's still a width. And we called that width delta x, but since delta x was approaching 0 when we did the integral, it became dx. Now, what did the height of the rectangle represent? It's just the y value. It's whatever the function is. So this height was just whatever the function is. Then when we rotated around the axis of revolution, let's say the x-axis since it's convenient, when we rotated around the axis of rotation, then we took this one rectangle, and you can imagine that vertical strip rotating around. And if you took a strip of paper, okay, if we took a strip of paper and we rotated it on an axis of symmetry, what do we have now?
Pretty thick cylinder.
We have a cylinder. We have a disc. We have a hockey puck. We have a can of dog food, or cat food, as they wanted to say last hour. I don't know why they were stuck with a can of cat food, but it worked. All right, so what you ended up with is this shape. And the key here is understanding the volume of a cylinder is calculated by pi r squared times h. Agreed? Pi r squared times h. Well, where is the radius? Well, the radius is from the center to the outside of the circle. Well, what is the radius as we go back into our two-dimensional plane and we're taking that strip? What part of the strip is actually the radius? It's f of x. It's the function height. So the radius squared was just the function squared with the pi still. What was the height of the cylinder? There's the height, but what is that off your vertical strip? That's your delta x. That's the width of the rectangle. And then that was just one vertical strip. So we said, okay, we can find the volume of one disk by taking one vertical strip and rotating it, but we don't have one strip. We have an infinite number of what? Rectangles. Therefore, there are an infinite number of what? Disks. Okay? And so what happened is this formula changed over, and delta x, when you throw the integral in front of it, so the volume said, if we want to add up all those disks, we threw the pi out front, we went the integral from A to B, we still had the radius squared, but the delta x became a dx because that width becomes infinitely small, and that's what dx represents as a width approaching 0. And that's where it came from, the limit definition. So that's where that formula came from. All right, let's go through the steps and we'll look at some of the examples you were supposed to try and set up. So we have the 4 formulas there. Here's the steps to find volumes of revolution. Step 1 is going to be to sketch the area of the region you're going to rotate. All right, look at me. This is so important. If you can't see the area, you're not going to be able to see what the radii are. Now, I'm going to do some things that some of you are going to feel like they were just all over me this morning. So cut me some slack, okay? All right? Not, I didn't do anything wrong. I did everything right, actually. It's just I'm going to show a lot of steps here because I want to make sure everybody gets this because not everybody's going to be able to do parts of it in their head. So figure out which parts you can do in your head and figure out which parts you need to write down, and that's up to you. But I'm going to tell you right now, this part is so important because if you don't know the area you're rotating, you're not going to be able to find the radii. Okay, now I don't care if you visualize it in your head or on paper, you got to be able to see the area. Everybody, you got to be able to see the what? Area. So first step is going to be to locate that area. Second step, determine if it's a disk or washer. Now, I clarified this, I thought, pretty hard this morning, but some of them still didn't get it, so let me make sure I clarify just as hard, and if not harder, with you guys. A disk, the area of the region, must completely be filled to the axis of revolution. If there's any area, if there's any white space between that area and the axis of revolution, it's not going to be a disk.
So does that just mean it has to be flush?
It's got to be completely flush, completely. If there's one place where it's not flush, then you got to carve that out. Okay?
Well, that'll be a wash.
Yep. If the washer is the area of the region is not complete, which means there's a gap between the region and the axis of revolution. And if there's a gap, I don't care if there's just a little gap. I don't care if there's only a gap at the end. And if it's flush all the way up until you get to the end, then there's no, and it's not touching there. If there's a gap anywhere, then you have to do a washer. You have to carve part of it out. And sometimes just imagine a cylinder and just kind of carving. You ever taken a big tub of ice cream and just carved out part of it? You didn't stamp all the way through it, did you, to get your ice cream out? You just carved out the top. That's really what we're doing here. Now sometimes we're going to punch the whole thing out. And you'll see a hole through the whole thing and be like, oh my gosh, there's a hole through it. Okay? And that's fine too. Alright? Imagine kind of like cookie cutters. You know? Sometimes we punch the hole all the way through and we remove it. Sometimes we just carve part of it out. Okay? Alright? You're so hungry?
Yes. Sometimes.
Sweet, we'll go to third lunch. If disk, draw a vertical strip to represent the radius. Okay? If it's a disk, draw a vertical strip to represent the radius. If it's a washer, draw a vertical strip to represent the outer radius and another one for the inner radius. Remember, you always measure the radii from the axis of revolution. We're always going to mark off that radii from the axis of revolution. I had a little bit of a problem with that. I'll tell you why in a minute. And when you calculate the radius, you take top minus bottom if it's a horizontal axis of revolution, and if it's a vertical, you go right minus left. Okay? Once you find the radii, plug it into the correct formula up here, and then use the integration process and calculate the volume. Once you get to step 4 and 5, you're not going to need my help anymore. If it can get you past step 3, 4, and 5, you'll be like, okay, fine, leave me alone now. I know what to do. Okay? That was the experience today. And sometimes they're like, can we use the calculator? And I'm going to tell you, at times I'm going to allow you to use the calculator. On the AP exam, all the free response are calculator when you do an area and volume, so you'll just have to set it up. So that's really what we're going to practice today is the setup. We're not going to do a lot of calculating by hand. We'll do a couple by hand, but we're going to do a lot of practice on the setup. Make sure you get these things set up correctly. So let's set up the first 3, and then we'll stop and take a break for lunch. We did example 1. I had just gotten done with 1 before we left. So I'm going to pick up with example 2. I'll do 2 and 3, and then we'll go to lunch. Okay, well, the directions tell you. What did they tell you to rotate it around? They told you in the directions to rotate it around the x-axis. They have to tell you that. Okay, so in the directions, there's going to be somewhere it's going to say rotate it around this. In the directions it said, so examples 1 through 6, it said rotate around the x-axis. So first step, draw the what?
Graph.
The graph. Okay? So we're going to have 4 minus x squared. So we're going to go up 4. We're going to draw a parabola. And now this one, there was a little bit of ambiguity, and I'll tell you why here in a second. Now you got y equals 0. So that's this, and we got x equals 0. Now here's what they had a problem with, and I agree, actually. I actually agreed with them. You've got boundaries. You've got the curve, you've got the y-axis, the y-axis, and you got the x-axis. Well, it could be here or here. Which one is it? Does it matter?
Two different angles?
No, it's going to be the same.
It's going to be the same answer, so just pick one. Which one do you guys want to pick?
Do you want to include both of them?
They don't want to include both, so which one do you want to pick?
Right.
Let's pick the right one. If we pick both of them, the area is going to be double. Well, the volume is going to be actually the whole thing. We don't want the whole thing. They only want part of it. Okay, we're rotating around this. So imagine if you do rotate this, it kind of looks like a lemon or something like that. Basically, we're taking half of the lemon. We're finding volume of half of the lemon, or half of the grapefruit, or half of the whatever, half of the football, if you will. Okay? So we're just going to do this part. We'll just assume quadrant 1. Now, some people are going to like, well, am I going to have to figure out? No, they will absolutely clarify. I left it out. Okay? They will absolutely clarify what they want. You won't know. You won't be like, well, which one do they want? No, you'll know. It'll be very clear which one you want. Okay? So, Here's the key. We've done the first step, find the area. The second step, draw a vertical strip. Now people are like, I don't really need to do this. I'm just telling you, I'm going to do it every time because it helps, especially when you get to the harder ones. If you don't do it on the easier ones, you won't know what I'm talking about on the harder ones. So even though you don't need to do it, do it. And then after this, you can decide when you need to do it. But let's do it on every one today, just so you can see why it will be a benefit when we get to the harder ones. Right now, it's not that big of a benefit. We're just visualizing. Okay? So the vertical strip, always measure from what? I need everybody to say this. See, I can't have anybody fishy about this. Where do we measure from? The axis of rotation. You always measure the vertical strip from the axis of rotation. So I'm going to measure from right there. Now, somebody said, well, where does it matter? It doesn't matter. Okay, because how many heights are there? There's an infinite number. I'm just doing one. Okay, there's an infinite number. There's one down here. There's one here. There's one here. I only need one. And the only reason I need one is because this thing represents the what of the disk.
Or the
When you rotate it, it'll become the radius. Now, the radius is always changing because this function's always changing. Why do you think we use a function to represent that value? That drives me nuts. Why do you think we use a function to represent that value? I can't even do anything with it either. Oh well. We'll just have to go with it. All right, so I'm going to represent r of x. Oh, there it goes. I'm going to represent r of x now. Now, how do you calculate that distance from here to here? What have I told you to always do? Top minus bottom. So which one's the one on top? 4 minus x squared. What's the one on bottom? 0. Now, for a lot of these, it's going to be 0 right now. It's not going to be 0 in a little bit. When we get back from lunch, it will not be 0 anymore. And some of you will be confused because you haven't paid attention to this vertical strip thing. The vertical strip is the most important part. The area and the vertical strip together. You get those two things. If you can see the area and see the vertical strip, I know you guys can plug into a formula. That's not the hard part. Once we get this, let me say, we're pretty much done. Because now you just simplify your radius. There's your radius. You just plug it into the formula. Which formula? Well, did we decide? Is it a disk or a washer? It's a disk. Why? Because there's no gap. We're rotating it around this. There's no gap there at all. There's nothing we got to carve out or subtract out. So it's going to be pi times a definite integral. Now, we have to figure out the limits of integration. How do you figure out the limits of integration? It definitely looks like 0, but how do you know what this is? You have to set the parabola equal to what? You got to see where it crosses the x-axis. So you had to set the parabola equal to 0. Now, I think most of you can do that in your head. What is it going to be? It's plus or minus 2, but we're doing the right side, so it's going to be the 2. So it's from 0 to 2. And the formula is what?
R of x.
It's pi radius squared times height. So radius squared, what's the radius? 4 minus x squared squared, and then the height is the dx. And I'll finish this and then we'll stop and go to lunch. Okay? Hold on. Hold on, I'll let you come back. I'll let you come back late. Alright, just let me finish this one so I can stop and play for the video. So it's pi. There's a line anyway, so just get over it. Alright, so from 0 to 2, what would you do next? Thank you. Okay, use substitution is a last resort, y'all. I know that we've been doing homework on use substitution and everything was use substitution. But use substitution really is your last resort. You should never think use substitution in the beginning. You should always be thinking, can I do this without use substitution? And what do you always do to do without use substitution? You try and rewrite it. How do you rewrite this?
You have to.
So it'll be 16 minus 8x squared. It'll end up being plus x to the 4th dx. Does that make sense? All right, let's finish this. Pi. All right, so we're going to have, it'll be 16x, right?
Minus 8/3 x cubed.
Minus 8/3 x cubed.
Plus x to the 5th over 5.
From 0 to 2. And without a lot of hoo-ha here and getting all yourself all frustrated, it's ugly. And it could be non-calculator. When can you multiply by the pi? Last. And I believe it, I can't remember exactly what the answer is, but I believe it's like 300 and something over 15.
Right.
It's like 320 pi over
So
15.
you gotta make that 16 times 2 into it.
Yeah, you have to, when you plug the 2 in,
256 pi over
huh?
256 pi.
That was it. It was 256 pi over 15. And the way we got that, and then I'll stop, is you plug the 2 in first, you figure out the 2 minus 0, which is just 0, and then when you find that, you multiply by pi. Alright, so you guys come back, we'll start at like 13 after, 13, 14 after.